All right, so now specific arrangements in a circle. So we can actually use permutations for when we want to work out arrangements around a circle. But when we use this instead of just the other way is when you first need to select a certain number of people. So for example, out of 20 people, you first select 6 people and then you arrange them around a circle. And that's why we have NPK divided by K. So out of N people, I select K people. And out of those K people, I then arrange them. And remember what we talked about in factorials. If we have 8 people in a circle, if they were in a line, it would be 8 factorial. But if they're in a circle, there's actually 8 repeats, so we divide it by 8. And in the same way, that's why we divided by K here, because we're getting rid of the repetitions essentially. Okay? So just remember that you're dividing it by K because you're getting rid of the circles that are exactly the same, that are identical. So in question 6, we have a round table seating 5 people. But in this case, we want to choose 5 people from a group of 8 people first. And then we want to work out how many ways those 5 people can be seated at the table. So I kind of try and consider this in 2 steps. So the first step is I select 5 people from 8 people and then I arrange. So that's why I have 8 people, P5. So out of 8, I'm getting 5 people. And then I arrange them in a circle. Now, because they're arranged in a circle, there's going to be, the circle only has 5 people in it. And when we had 5 people, we had 5 identical tables. So that's why I divide by 5. So getting rid of the identical tables. And that just gives me, so you can just put that in your calculator, 1,344 ways. Now, let's have a look here again because I just know there are so many students that get so confused by this. But what I'm doing is breaking it down to 2 steps. So first of all, I see from a group of 8 people, I want to get 5 people first. So that's why I do 8P5. Now, I know order is important because they're arranged. Can you see that? They're seated or arranged around a table and people can't be repeated. So once I've gotten those 5 people, I think to myself, now I'm going to arrange them around a circle. Now, when you arrange something around a circle, you need to divide by how many identical tables there are. So in this case, 5 people, are seated in a circle. So that's why it's divided by 5. All right, does that make sense? Good. So if you can get this, trust me, you're doing better than most people because it is a really difficult concept. So this is working with people. Let's move on to working with necklaces. So remember how necklaces and bracelets had their very special thing, which was that you could actually flip them around and they'd be exactly the same. So here we want to find out how many different necklaces of 5 beads can be made out of 8 different beads. So this is a diagram that we had in factorials which showed you how with a necklace, you could flip it around, it'd be exactly the same, which means that we need to divide however many arrangements there are by 2. Let's work this out in the steps that we did before. So from 8 beads, I want to select 5 beads. So that's why I'm going to have 8P5, right? That's where I get that from. Now I have the 5 beads already and I want to put them in a circle. So that means there's going to be 5 circles that's exactly the same. So that's why I divide by 5. And now, because it's a necklace, it means I can switch them around, So that's why I need to divide by 2 or multiply by half. So can you see how I've broken that down to steps so that it's actually really easy? And you can just put that in your calculator and you should get 672 ways. So the common mistakes that I see most people make when you work with permutations in a circle is you get a bit confused about what you divide by. But just think about if I'm getting 5 people, choosing 5 people from 8, only those 5 people going in the circle. So that's why you divide by 5 and not 8, okay?